Bry. I'm coming over from Google from the Android Security Assurance Group. No, we haven't changed the name so recently. I haven't even updated the slides. Any of y'all working on Android? Hammering on Android? Okay, no. We got a VRP. We take in bugs, pay people for them, and biggest part of my job is checking on those bugs and seeing how bad they are. So I wanted to share how many times I've just done this over the last year or so. I hope you get a kick out of some of them. I don't do this alone. We got about 20 people scattered between Kirkland, Seattle, Mountain View, a couple in Austin, and hey, come on in. No, don't come in. All right. Just checking to make sure there's anybody here, I guess. Question? Oh, okay. Well, the door's already closed by then. We're hiring, as many people are. We've got sibling teams in the Bay Area, sibling teams in London. Wherever you want to work, we can work it out. I think we've got a couple of people just working remotely at this point. A lot of our bugs are just really boring. All the reports look the same. These are all CVE numbers just from the kernel and these are all CVE numbers just from kernel memory corruption. If kernel writers were good at their job, I wouldn't have a job. So thanks to all these people, use locks, check your inputs. Apparently it is this difficult. I haven't tried. Media server, almost as fun as the kernel. It is highly privileged. It has to be pretty close to the hardware. It has to be have various permissions for DRM and nonsense like that. So yeah, more CVEs just from people fuzzing the media server, fuzzing all the codecs, hammering on stuff like that. All of these people got paid for sending us these bugs. That depends on the severity. I'm not really sure what the rating. Criticality for bug and a POC, I think it's upwards of $3,000. Yeah. Most of that money comes in is actually for the POC. If you just say, hey, here's a bug here, and we have to duplicate it ourselves, we'll give you like a third of that. But then if you say, hey, here, run this file, it'll crash your phone. Cool, have some money. Problem with the media server is most of that data is coming in from the internet. Critical is reserved for remote access bugs at this point, basically. If you get execution in the trust zone, that's critical as well. But media server execution from a remote file is also critical bug. So yeah. Sorry. That's not necessarily in my department. That's more what the PMs do. But I believe you have an account with the payments, and that's for finance to deal with. That's not my job. Yeah, maybe, I don't know. You could probably just get a check. All right, you want to see the good stuff. I also get to see the big stuff early. Anybody recognize these CV numbers? See some nods in the back. I got an email from my boss last August. It was something like, we got this new bug coming in from Project Zero. We work with Project Zero a lot. They're real good folks over there. It's going to be bad. It's going to hit basically everything in the world. Don't talk to anybody on the team about it unless they already know. Figure out how bad it is on Android. And I'm going to Gen Con. See ya. Looking more familiar now? Yeah, I got to see Spectre and Meltdown about 5 months early. By the time it got leaked and finally disclosed, I could just be like, all right, y'all's problem now. Have fun with that. So the big part of my job was moving the POCs in there from top-end Intel down to like Atom and ARM processors, making sure it hit there, and helping out with some of the fixes on those. And that's, we get to work very closely with those teams. Yeah. If you ever get a chance to see any of the people who worked on this talk about it, real good stuff. All right, some things never change. Bugs never change. Find new and exciting ways and places to appear. Command line arguments. Why does the kernel have command line arguments? It's a phone, it doesn't have a command line. So a couple phones, a couple of versions of the bug, they were just pulling command line arguments from an unencrypted partition and stircatting them into command line on the kernel. And kernel command line arguments just don't deal with spaces. So you could just stick whatever arguments you wanted there into that. That turned out to be a critical bug because you could just reflash that partition, no checks, no anything, get access to debug features in the kernel. Time of check, time of use, we all are familiar with this. Media provider, this was something going on in the media provider where media provider has access to all the files on the device, but it checks when it has a client making calls to it, it checks what permissions that client has. So if you give it a symlink, it will check the permissions on that symlink. Then you change that symlink and it goes ahead and dereferences it and gets to whatever file you want. Good job on that. That turned out to be moderate information disclosure. More fun stuff, dev tools. There's all sorts of things. Why is this keep changing Zoom? There's all sorts of things you want to do to your own code. You don't necessarily want other people doing to your code. Anybody playing Pokemon Go still? They've been doing some cool stuff recently, the raids. Yeah, gotta have a test interface for that. You don't want to have your people all running around Paris while they're developing your code. So you have mock location data. You put your app into debug mode. You can just start say, hey, use this data. Go ahead and do this. And there's been a few different APIs. We're on API level 28 at this point. Android Pie releases this month, I believe. So we've got had a few different APIs for mock location data. The basic idea is that when you set a mock location, the location data that comes down to the app just has a flag in it that says, okay, this isn't real location data, but use it if you want to. Use it if you're in debug mode. There's just one version of the location API that just didn't correctly set that flag. If you use the just correct set of calls, it would just forget to set the mock location data. So sorry about that if you're not actually being able to cheat on the Pokemon anymore. That was a moderate bug. Another quick one, deeper into the dev cycle. We needed a way to be able to check and make sure that a partition had the version we wanted in there. So we just said, okay, pull a hash of the partition, and then we can say, okay, this hash matches this build, this hash matches this build. But now someone bothered to extend that to get a hash of a section of a partition. So you could get a hash of the first 12 bytes of the partition. You could get a hash of the first byte of a partition. So you just load the phone up into fastboot, just say, because you don't want it, like, the goal was not to be able to read every partition data directly off of there, just be able to get, like, the hash. We made it possible to get all the data with a simple lookup table. High severity, because not everybody was using full phone encryption at the time. Password complexity. Whole point of a password is you know absolutely nothing about what's in it, right? So what's this file doing here? You could just grab this file off of there. Even if you have file-based encryption on the phone, like, yeah, you pull this file off that's encrypted, but then, like, this is a very easy format. You could brute force this file really easily and then try to get a lot more tasks for brute force, a lot more guidelines for brute forcing a password. That turned out to be moderate severity. Excuse me. Oh man, this one was fun. It was only actually hit on one device. A lot of phones these days have an extra, is that a question or no? Okay. A lot of phones these days have an extra interface and a headphone jack, or they did when they had a headphone jack. That, like, if you're using this in a factory, if you've got the USB plugged in for some loading, you've got a debug port interface in the USB jack as well. Most of the time that's just disabled before you ship it out. You just blow a fuse, and on the production models, just send it right out the door. If you have a Nexus 9 though, you have a full serial port interface in your headphone jack to a kernel level debugger. Yeah, read absolutely anything out of kernel memory, out of anywhere on the phone. Yeah. Have people actually made debuggers that use the 3.5 millimeter? Clearly somebody has because somebody found this. This is like, the 3.5 millimeter cable is a known interface for all these phones, right? Like, it's not just tip, ring, sleeve. If you have the 4 ports on there, then it's putting, like, if you have a headset with command buttons on there, that's how they're sending those commands into the phone. And now we've just got a serial interface through that too. Only on the Nexus 9. Maybe that's a good reason that people don't have headphone jacks anymore. We called this one a critical, actually, because this was kernel level access straight into the phone. Weird binary formats. Every operating system has its own weird special formats, weird special things going on with old familiar formats. What's going on here? This was my favorite bug that I actually looked at through anywhere, any time of this. Where's my cursor? Yeah, accessibility services. You have a service on your phone that can absolutely touch everything. It needs to be because it's for screen readers, it's for disability services. It can touch absolutely anything. And we're on the 28th iteration of the API. These tools have changed a while, and we need backward compatibility because if you went to the Android app pen testing talk yesterday, you saw the spread of quarter of the people are on Marshmallow, quarter of people are on quarter of people are on Nougat. So we got to have backward compatibility through all of these things. And how it works now is you send your accessibility info into the system server. It cracks that open, looks inside, just makes sure that you have permission to do all those things, packs it back up together, and sends it off. So we've gone through enough versions that the serialization has gotten a little out of sync. So if you craft your input just to this, just so, then you put the label into the string, and then when it reserializes after packaging that string back up, all that data that you put in as part of the string is now just a separate bundle and a separate intent. And since this intent is being sent back out to the rest of the system from the system server, you now have permission to run basically anything out of that intent. You can say, hey, change this label into go download and install your favorite malicious package. Go get your keylogger. We called this high code execution. This one was also super cool because we have 2 different formats on the phone. The APK, which is a zip file, dex file, which is your binary code. And then with the format weirdness, the APK, since it's a zip, can have arbitrary data tacked onto the front. The dex file can have arbitrary data tacked onto the end. You can just jam those together, and now it's both a valid dex and a valid APK. In earlier versions of this signing scheme, I'll remind you that everything I'm showing here has been fixed. In earlier versions, the signature on that APK only covered the APK data itself. So you could change that extraneous data at any point to do absolutely anything else you wanted. So if you have your dex file on the beginning, your APK file on the end, the APK file is a valid build of Google Maps version 27.3.4. Your dex file on the beginning is your malware. Then you can download that onto the phone, checks the signature, okay, this is a good upgrade, I'll just upgrade maps like that, great, thanks. And then it goes to run it, sees that dex data, it runs that instead. Oops. Yeah. So, called that high severity again. All right, here's some stuff that's actually pretty unique to Android. Permissions shenanigans, there's been a lot of this stuff going on. Everything in Google, or everything in Android is gated on a permission. You want to access the internet, you request a permission for that. You want to get Bluetooth admin privileges, you request a permission for that. Some of these go to the user for confirmation, some of them don't. There's a lot of permissions that are actually only granted to apps that are previously installed, apps that are built into the system image, or share a signature with apps that are built in on the system image. But for enterprise users, you can have a policy client that's running a restricted profile. So if you have your have a work profile for your users, the only things that can access your corporate email are coming out of that profile. User can be running whatever else they want on their own profile on the phone. But then the administrator for that, 10 minutes, thank you. The administrator app for that profile manages permissions for everything running inside that profile. But then you grant permissions to something inside the profile, it comes back and grants that permission back to everything outside the profile, back to that same app that's running outside the profile as well. So you can say, hey, I want this app inside the I want to install this app inside the profile, inside the secure profile, give it the right secure settings permission so it can set whatever it wants to on the phone. Now it can run outside the restricted profile. High severity, get basically admin access everywhere on the phone. More stuff with version management, you get permissions, you can combine permissions into permission groups, so when one is granted, everything in the group is granted. You can have apps, you can have danger levels within a permission, so you can have the permission that doesn't, you can have things like internet permissions, which don't ask if the user needs them because everything needs internet permissions. Or you can have dangerous permissions for things like contacts. It pops up the little screen on there and says, hey, this app wants to do this. Go ahead. But you can also put your permissions into permission groups from other apps. So and then when you upgrade your app, it also updates all the permissions on those apps and all the permissions you had there. So what you can do, once a permission is granted, that permission stays granted even if you've increased the danger level. So if you give it if you create your app and put it into the if you create your app with a permission that's in the microphone group, and it's just a regular permission, now your app has everything that is inside, all the regular permissions inside the microphone group. Now you upgrade your app and you upgrade your permission to dangerous. That permission is now in the microphone group at the dangerous level, so your app has access to everything at dangerous level inside the microphone group. You just grab microphone access, just straight up like that. Whoops. A lot of things you can do, a lot of other ways. A lot of ways you can do things inside your own app. You can draw something just in front of everything. Which one is this? Yeah, you can draw windows in front of everything on your app if you need to draw. It's early, can you tell? Manage an overlay permission inside your app, great, that's fine. If you want to do this on the system, on the full system, you can still do that. You see things like Facebook doing this all the time with this little head bubbles. You can still get a permission to do that, system alert window. It's a restricted permission, it's a dangerous permission. You can still get it. So, but that's like, yeah. But we had a problem for a bit where if you were working with an app, working inside an app and it had its overlay, you switch over to another app, that overlay would stay. Yeah, the original overlay was still there. It would then be used to block things like other permission dialogues, other useful information coming out of the system. But it gets worse, because while you're drawing that overlay, you don't necessarily receive touch events, but you do receive at least a hint of what touch events are going on. So if you're drawing over something, that can get a little obvious pretty quick. But if you're just drawing invisible surfaces, you can start getting, you can make these surfaces so they're not getting touch events, they're not getting any interaction. The only sort of data that they're getting is the touch on a surface that's in front or in back. All these surfaces are drawn with a Z order. They're drawn in order. And then if you get enough surfaces there in enough different places, you can just really start to work out where on the screen that touch is being drawn. So at this point, you have a full screen overlay. You have pretty good resolution as to what's actually being touched where. Just put one little surface over every key on the keyboard. Yeah, so if you adjust your keyboard size or if you adjust your keyboard layout, remember that you were messing with malware developers. By a quirk of our severity ratings, previous one was rated as high. This one was rated as moderate because it takes just a little more effort to get to, needed to exploit a previously existing bug. And then there's the real problem with the apps. Weakest part of any computing system is the users. If you send an email, you can just say, hey, attach any file on the system to that, and then the email app can send any file it has access to, which can be its own key store. This bug actually showed up in both the open source mail program and Gmail, so we had to fix that in both places, but Gmail is part of the main Google VRP, separate from the Android code. It's the same one, that was a high severity. String processing, string handling, yeah, we handle new lines. You hook your phone up to your watch, you see a dialogue something like this. You hook your phone up to some other device that has a name something like this, but it actually looks a little something like this. So yeah, it looks pretty innocuous. Since then we've moved a lot of the placeholders and strings around, so arbitrary strings always go to the end. I'm kind of hurrying through these last few because I've got a few minutes left. All right, there's a lot going on here. This seems bad. I haven't thrown out my phone yet, so what are we doing about it? We have a lot of PMs on the team whose job is to find the people who are responsible for fixing these things. We have the highest PM to engineer ratio, I believe, of any team in Google, just to make sure all these things get done, all these things get fixed. And then we also have the authority to just fix it ourselves. We find, like, here's a bug in the kernel, I've got kernel push access, I can just get this change in. And then the other part of our job is to actually review the features that are coming up in later versions of Android, and every feature that comes into Android comes across my desk, comes across my team's desk. We can say, okay, hey, you're changing the icons from rectangles to rounded rectangles. Good, seems fine. Oh, you're creating a new camera hardware interface. Who's going to have access to that? How is that going to be controlled? What can that actually do? Are you sure you want to do this? And we even have the power to spike a feature if it's just not going to be something we can deal with. And what can you do about this as developers? All the same things you always do when working with apps. Don't trust your inputs. Don't trust your users. Fuzz all your stuff. Find everything. And if you find stuff, send it to us. Go g.co, Android security rewards. That should have data on all the pricing, all of our pricing structures, all of our recent severity guidelines. Yeah. We got a few minutes left for questions, if anybody has anything. I know it's still early. All still tired from the shows last night. So yeah. Thanks. Thanks everybody on the live stream too.